Welcome you all to the video lecture on signals and system. Today we are going to find out the transfer function impulse response for the given difference equation. So the given equation is y of n minus 5 y of n minus 1 plus 6 y of n minus 2, that is equal to x of n. So since we are going to discuss about discrete system, we can apply Z transform here and we can find out the transfer function and also the impulse response. So transfer function is given by h of z, which is nothing but y of z by x of z. So first we need to apply the Z transform for this equation and we need to find out the transfer function h of z. So the given equation is y of n minus 5 y of n minus 1 plus 6 y of n minus 2, that is equal to x of n. First let me apply Z transform on both sides. So Z transform of y of n is y of z, that is equal to 5 into Z transform of y of n minus 1. So usually Z transform of y of n minus m is z power minus m y of z. So using this formula, we can write for y of n minus m, it is z power minus 1. Okay. So here I have y of n, for that I have y of z, and then I have minus 5. For y of n minus 1, it is z power minus 1 y of z plus 6. For y of n minus 2, it is z power minus 2 y of z, that is equal to x of z. So take y of z commonly outside in the left hand side. So you have 1 minus 5 z inverse plus 6 z power minus 2, that is equal to x of z. So y of z by x of z is given by 1 divided by 1 minus 5 z inverse plus 6 z power minus 2. So this is nothing but your transfer function. It is also called a system function. So the transfer function x of h of z is nothing but y of z by x of z. So since we are going to find out impulse response, okay, so it will be easy for us to convert all the terms into z terms, positive z terms. So convert your inverse z terms into positive z terms to multiply and divide by z square in both numerator and denominator. So what you can do, so convert all terms into z square terms. So because a higher power is z power minus 2. So multiply by z square in both numerator and denominator. So I have 1 into z square as z square. Denominator I have z square minus 5z plus 6. So this is my h of z. So next we need to find out your impulse response. So for finding out your impulse response, we know that your x of n is given by del of n. So when you apply z transform for x of n, x of z is nothing but 1. So already we know that y of z by x of z is z square divided by z square minus 5z plus 6. So in this term here x of z is 1. So we have just y of z is equal to z square divided by z square minus 5z plus 6. Okay. So here in your z transformation, so when you want to find out your impulse response, we need to apply partial fractions. Again, before applying the partial fractions, we should take 1z to the left hand side. Okay. Why? Because in all the formulas we have z by z minus a like that. Okay. So in order to make properly use your formula or apply your formula, in the first step before applying the partial fraction, we need to take 1z to the left hand side. So we have y of z by z. So take 1z to the left hand side, it becomes z by. So factorize this term. So you'll be getting z minus 3 into z minus 2. So I can apply the partial fraction now. A by z minus 3 plus b by z minus 2. So left hand side you have z, right hand side you have a into z minus 2 plus b into z minus 3. So now substitute z is equal to 2. So you have 2 is equal to, so this term get cancelled. B into 2 minus 3 is minus 1, which implies B value is minus 2. And then we can substitute Z equal to 3. So again left hand side it is 3. A 3 minus 2 is nothing but 1. So which implies A is equal to 3. So we have A is equal to 3, B is equal to minus 2, so that we can substitute. So A is equal to 3, B is equal to minus 2. So y of z by z is 3 by z minus 3 minus 2 by z minus 2. Okay, so this is the term what we have. A value is 3, so 3 by z minus 3, and B value is minus 2. Okay, so minus 2 divided by z minus 2. So now take, after applying the partial fractions, after finding your values A and B, now take z to the right hand side. So 3 z by z minus 3 minus 2 z by z minus 2. Okay, so now we can apply inverse Z transform, so that we have y of n is equal to, so 3 into, applying inverse Z transform for this, we have 3 power n u of n, and minus 2 for this term it is 2 power n u of n. Why? Because Z inverse of z by z minus a is a power n u of n. So using this formula, here z by z minus 3 means we can write it as 3 power n u of n. Here z by z minus 2 means we can write it as 2 power n u of n. Okay. So this is my impulse response. Thank you. Thanks for watching.